Hello students! This is your video with some friendly reminders and some help from chapter 1. The first thing we're going to look at are Venn diagrams and naming things, because these were the areas where I saw the most mistakes in the homework that were handed in this first week. So I want to go over how to do some of those Venn diagrams that were in your homework. So you guys have seen these, and I just want to show you how to do them because I know that they're going to come up again in the review that you're going to work on later next week, and they'll also be on the test. So I want to go over these, make sure that you have a better understanding of how to draw these Venn diagrams, how to shade the different areas, how that works out, and then also naming things, because I saw that we had some confusion about how to name some of the segments, rays, or lines that we were dealing with in the first couple of sections. So let's get started. So our first problem comes to us from section 1.1. It was number 23 in the homework. They gave you the sets M and P, and they asked you to draw a Venn diagram for it. So each of our Venn diagrams is going to be in a box, and we take a look at these two sets. So M has 2, 3, 4, 5, and 6. And notice that set P has 3 and 5. The important thing to catch in this one, as I saw a lot of you were trying to draw the two circles that had a little bit of a connection in the middle. But the important thing to catch here is that everything that you see here exists in here, right? Everything that you see in set P exists in set M. That means that set P, if we were going to draw this accurately, would be completely inside of set M. So to draw this, we would draw our larger set, and this would be our set M, and we would draw our smaller set inside of it. It's not really important where inside of M you draw it, just somewhere completely inside of it, because everything that exists in P is also inside of M. And here's our U for universal. So I'm going to start out with P. Okay, P has the elements of 3 and 5. All right, so those are in P, but notice they're also in M, so they're inside of the big circle of M, which means that we've already taken care of 3 and 5 being inside of M. What else is inside of M? We've also got 2, 4, and 6. So I'm going to put those out here, 2, 4, and 6, because those are also elements of M, but the 2, 4, and 6 are not elements inside of P. Okay, those don't belong to set P, only 3 and 5 do. But do you see how then set P, the 3 and the 5 completely are completely within set M there. So this would be the proper way to draw the Venn diagram for that problem. Okay. Then we had several problems that used the same sets K, L, and M. And you were asked to do different Venn diagrams based on these sets here. Now what some of you did was you drew 3 circles for each of the problems, even if they only had 2 sets that they were wanting to compare. Technically, that's fine. You can do it that way. I didn't take off points as long as you shaded the correct sections that they were talking about here when comparing these 2 sets. Okay, so it's okay if you ended up drawing the 3 circles. I didn't take off for that as long as you shaded properly. But you didn't really have to draw the 3 circles. If we're only looking at comparing these 2 sets, then we really only need to draw circles for sets K and L for this one, number 31. So let me show you what this would look like. K and L. K has 0, 1, 2, and 5. L has 0, 1, 3, and 4. So what we see here is that they have some elements in common and some elements that are different. So we know that these 2 circles are going to intersect. They will have some elements in common and some different, right? So I've got K, and this will be L in my universal set. And so I'm going to start with, what do they have in common? They have 0 and 1 in common. So I'm going to put those here. And then K also has 2 and 5. And L also has 3 and 4. And then I have to look at the shading, right? Because we're looking at the intersection here. So the intersection means, what do they have in common, right? And what K and L have in common is they have the elements 0 and 1 in common. So we're going to shade this area right here in the middle. So that's what that Venn diagram should look like. Over here, we're looking at M union K. And so if we look at M has 0, 2, 3, and 6. K has 0, 1, 2, and 5. So again, we've got some shared elements and some elements that they don't share. So we're going to have the two circles intersecting in the universe there. We've got M and we've got set K. All right, so I'm going to start with what do they have in common. That's the easiest way to start to fill these in. And what they have in common for M and K, they both have a 0 and they both have a 2. Okay, so other than 0 and 2, M also has a 3 and a 6. K has 1 and a 5. All right, so then we look at, once we have all the numbers in there, what do we shade? Well, here we're looking for the union. Okay, union, remember, we're marrying these two sets together. So we're bringing everything from M and everything from K, all of it's going to be included. So when I shade, I'm going to shade everything in M and everything in K. Okay, so just inside the circles, that's all that gets shaded. We don't shade outside the circles, but everything in both of those circles gets shaded. And then we had two other ones in that same section. I want to be able to see my sets up there. Okay, so we had two other ones in that section, problems 33 and 38, that were also using the same sets that we have up there. So we had L and the complement of M. So if you remember this, the complement of M means everything that's not in M, right? So we'll take a look at what that means in just a minute. But we know that we're going to use our two sets L and M. And again, if we look at these, 0, 1, 2, or 0, 1, 3, 4, 0, 2, 3, 6. We see some common elements and some different ones. So just like the two above, we're going to have intersecting circles. Some in common, some not. We have set L, and we have set M, and we've got our universe here. So I'm going to fill in set L and set M, and I'll come back to that complement in just a minute. Right? So set L, and what do they have in common? They've got 0 and 3 in common. So 0 and 3. And then other than that, L has 1 and 4. And M has 2 and 6. Right? So we've got our numbers set up. Now we take a look at how do we shade this. So we're looking for an intersection, right? Intersection is going to mean what they have in common. Not the union, but we want the intersection, so what they have in common. So we want L, right? So here's circle L. So we know that we're going to be looking at the items or the elements in circle L, and we want M complement. All right, what's the complement of M? The complement of M is everything that's not in M, right? So we want everything that's not in that circle. So if I block out that circle, I want everything that's not in that circle. That could even include the things out here in the universe, right? So everything that's not in M is going to be what you see here in L, and it would be everything out here in the rest of the universe. But now remember that I want what L and the complement of M have in common. What L and the complement of M have in common. So what they have in common would just be this area right here, this part of L. Okay, that's what L intersect the complement of M would have in common right here. Okay, one more of these, and here this time we're going to use all three sets together. We've got M intersect K, and then we're going to take that and union it with L. So what we have seen so far with all of these other Venn diagrams that we've drawn is these sets all have some things in common and some things not. So what we're going to do is try to draw three circles representing our three sets, and they are all going to have some intersection and some not intersection, right? So we've got set M, we've got set K, and we've got set L down here. Okay. So when I'm going to fill in something like this, I find the easiest way to do this is to start with what they all three have in common. That's going to be this space right here. All three of them are going to have the same element. And is there something that they all three have in common? And if we look at this, they all three have 0. So I know 0 is going to be in each one of these circles, right? And that's going to be in this shared space right here. Then I could start to look at M and K. What is it that M and K share? I know that they share 0, but what else do M and K share? M and K also share the number 2. Okay, so I'm going to put that in there. I can look at K and L. What do K and L share? I know that they share 0, but what else do K and L share? K and L also share 1. So I'm going to put a 1 there. And then M and L, what is it that M and L share aside from 0? M and L also share 3. Okay, so if you take a look at this, if I cover up these two sections for K and for L, right? If I'm just looking at circle M, I've already got 3 elements in it, right? I've got 2, 0, and 3. So the last element that I'm missing, in M, that would be a 6. In set K, I've already got 2, 0, and 1. What's the last one that I'm missing? 5. And for set L, the last one I'm missing here is 4. So once you've got all of your numbers filled in, and a lot of you were able to get this far, there was some trouble in figuring out how to do the shading on this, but a lot of you were able to get your Venn diagram at least set up like this with your numbers. And at this point, then we try to figure out the shading. So we start with this part right here. Remember parentheses first. In order of operations, we do parentheses first. Same thing with the sets. So we're going to take the intersection of M and K. We only want what M and K have in common. So I'm going to look at here's circle M and here's circle K. And what they have in common, where those two circles overlap, is all of this right here. Okay, those two circles, M and K, overlap, and they share the elements of 2 and 0. Okay, so now I'm going to take that, so that section that I've just shaded in, and I'm going to take that and union it with L. So I'm going to marry this to my circle with all of L's elements, right? And remember the union, we're going to marry them together. So we want everything in that shaded area plus everything in L, right? Everything in that I've already shaded plus everything in L. So L is this whole circle. So that's going to include 3. That's going to include 1. And it's going to include the rest of that circle. So we get 4 in there too. Okay, so that's what that should end up looking like in the end. We should have 2 and 0. We should have the 1 and the 3 here, and also 4. Those should be the shaded areas. All right. Then the next thing that we had some issues with were naming some of the different segments, raised lines, and how that works. So I want to remind you that when you are naming these in your homework, if you're asked to pick something out of a drawing, or you're just asked to name, create a segment or create a line, and you have to name it, how do we do that, and what kind of symbols do we use for that? So the thing about this is that segments, rays, half lines, and lines, all of these have one thing in common, is that you want to use 2 letters to name them. Okay, you want to use 2 letters to name them. And there's an exception for lines, and I'll come back to that in a minute. But in general, we want to use 2 letters every time that we're naming segments, rays, half lines, and lines. And so the symbols that we're going to use, if we've got segment AB, we're going to put 2 letters together, and that's going to be our starting point and our ending point. And we use the segment symbol above it. But we have to make sure we've got 2 letters there. And this represents our starting point and our ending point for that segment. All right. For ray, we're going to do 2 letters, and the 2 letters are going to be our ray's starting point and then the direction that it's going. So this would indicate that C is our starting point, and it looks like that right there. It's kind of like the end point. I know sometimes we say end point, sometimes we say starting point, but basically we're just meaning like it's the point here where our ray starts, and then it's going to go in the direction of the next letter. It's going to go in the direction of D, and it's going to keep going, and that's why we use the arrowhead on that part of our symbol there, right? So the symbol for rays is going to look like this. It's going to look like a segment, but with an arrow on the right-hand side. Now, that symbol should always face in this direction. It doesn't matter in a picture which direction your ray is going. Your ray might go in this direction. This might be point C. This might be point D. And so it might actually look like this, where C is the starting point and it's going in the direction of D. And so your symbol goes in that same direction. But you know what? We also have times where we have this. We might have C over here, and maybe our ray goes in this direction, and maybe our ray goes in the direction of A instead, right? But it's going off to the left, and that's okay. Sometimes that happens. Sometimes our rays go to the left. And the way that we would name this ray is we would say, again, start with the starting point. It starts at C, and it goes toward point A. So we would say CA, and we would still use our symbol, and our symbol's still going to point to the right. Okay, our symbol still goes in that direction. All right, so I hope that makes sense. For rays, you're always going to use this symbol, and the arrow is always going to point to the right. Your first letter here is going to be whatever your ray starts with, and then the second letter is going to be the direction that your ray is going, where your ray starts and the direction your ray is going. Now, some of you might say, well, what if there's more than one letter over here? So what if I've got C here, and then it's going in this direction, but there's a B, and there's also an A. Can I name it as CB, ray CB? And the answer is absolutely. You just need to name something else that's going in that same direction. So CB and CA, those would be the same ray because they're going in the same direction. All right, then we have half lines. And so half lines, let's say we've got half line EF here, and it's similar to a ray, but it does not include that starting point. So we name it very similarly, right? Again, it's very similar to a ray, but it does not include the starting point. So what this would mean is that it's the points just to the side of E and everything in the direction of F, right? Just to the side of E and everything in the direction of F. And it's going to keep going in that direction. Okay, but it doesn't include the first point, and that's why we put an open circle there. And then lines, excuse me. So lines, again, we want two letters, and the symbol above it is going to be a line symbol. So we've got the arrows on both sides of that, and it's important that we use the right symbol there. So lines, generally speaking, you're going to use two letters to name a line. The one exception is that sometimes you'll see the lines might have like a cursive or an italic letter. So they might have like a cursive or an italic M there, or maybe a cursive or an italic P. You can then name it with line M or line P. Okay, you can do that if there is a cursive or italic letter there. If there is no cursive or italic letter there, then you must name it with two letters, 2 points that are on that line. It doesn't matter which points you pick, as long as they're points on the same line, right? You name 2 points on that line, and you put this line symbol above it. When it comes to planes, we can use the little symbol, like a little parallelogram symbol, and then we need 3 points. 3 points determine a plane, 2 points determine a line, right? So 3 points determine a plane, so we can call this plane XYZ. You can also use the word plane XYZ, all right? And again, there is an occasion where a plane might be named with a cursive or an italic letter, usually in the upper corner. So if you happen to see that where a plane has, kind of similar to the line, a cursive or a cursive or italic letter in the corner of that plane, you can name the plane by that one particular letter. But most of the time, we're going to name our planes with 3 letters. Okay. Then we've got angles, and I know that was something new this past week. So angles, just as a reminder, angles you can either use 1 letter or 3 letters. 1 letter or 3 letters. So generally speaking, when in doubt, use 3. When in doubt, use 3. 3 will always be correct. Okay? It will always be correct to use 3 letters to name an angle, as long as your vertex is that middle letter. Your vertex, the point of your angle, right? To use 1 letter, so what we would do if we were going to name our angle with 1 letter, and again, we want to use these angle symbols. So if we're going to name our angle with 1 letter, we're going to name it by the vertex. And the only time that we can do that is if there's only one possible angle at that point. Okay, so you can name it with 1. only if there's just one possible angle. Missing that. Okay, at that vertex. So again, I could name an angle angle B, but only if there's only one possible angle at that vertex, at point B, right? So if I've got, so if you're wanting to know what does that mean, how do I know when there's one angle or if there are more angles, right? If I've got a picture that looks like this, and I've got point A, point B, and point C here, and there are no other lines, there's nothing else to the picture, then yes, I could absolutely name this as angle B. Okay, I could do that. I could name it as angle B. But if there happens to be one more line over here, and I've got another point D, I can no longer just name this angle right here angle B. I can't, because if I say angle B, I don't know if I'm talking about this angle, if I'm talking about this angle down here, or if I'm talking about the whole big angle. I don't know anymore because there's more than one possible angle at that point, right? So in that case, I would have to use 3 letters, right? So this is why I'm saying when in doubt, use 3 letters, because 3 letters will always be correct. Using 1 letter is a shortcut, but you can only do it when there's just one possible angle at that point, okay? So those are some of the helpful things from sections 1.1 and 1.2. All right, now for some of the homework helps for the things that you're working on this week, specifically 1.4 and 1.5. That's where I've gotten the most questions from you guys when I sent out the email this week and I asked you what are some things you could use some clarification on, or what are some questions, some problems that you're encountering as you're starting out trying to figure out some of this homework. All right, so I was getting questions on 1.4 and 1.5, so I want to go through these with you, but these are problems that are just like ones you're going to see in the homework, okay? So I'm not going to do your homework for you, but I'm going to give you examples that are going to be very similar to what you see in the homework so that you can take these examples, you can add these to your notes so that you have them in there so that you've got those when you're studying or when you're going back and trying to figure out the homework and how to do it. You've got these examples with you, and they're going to be very similar to what you have to do, okay? So the first thing in 1.4, unions and intersections of segments, rays, and half lines. This is usually a section where students get kind of stumped because this is new. This isn't usually something you guys have seen before. Even if you have done some unions and intersections and Venn diagrams before, depending on what your math background is, usually students haven't seen this before. So let's take a look at this. The first thing that I'm going to tell you is when you do these problems, having 2 different colors of pens or pencils or whatever you want to use, crayons, I don't care. Having 2 different colors helps so much, right? Again, I told you I'm a visual person, so I really like using my colors. So I'm going to get my 2 color pens here. And what I'm going to do is, in this first problem here, I'm trying to look for the intersection of ray BE and ray CA. Okay, so what I'm going to do is start with drawing ray BE. I want to draw and see what does that ray look like. I've got to see it to know where's my intersection. Okay, again, visual person here. And if you're a visual person, you'll understand this. So I'm going to start at B and go toward E. Here's B, and I'm going toward E. So I've just drawn in ray BE. Starts at B and goes toward E. Then I'm going to grab my other color and I'm going to draw in this other ray. I want ray CA. This tells me it starts at C and it goes toward A. So I'm going to start at C and I'm going to go toward A. Okay, so I see my 2 colors there, right? I've got that pink line on top and I've got that blue line on the bottom. And remember that I'm looking for the intersection. And the intersection means what they have in common. So what is it that these 2 rays have in common? Okay, so if I take a look at this, right? They've got this section right here to right here. They've got that in common. They've got that part in common. So to answer this problem, I would say that the intersection, it creates a line segment, right? Because it has a starting and an ending point, right? It's just a segment. It's just this space between B and C. So it's going to be segment BC. That's going to be my answer here. All right, so I make sure that I use my two letters, and I make sure that I use the right symbol above it. It's really important to use those right symbols that we just talked about. Okay, so BC. If you name it CB, that's fine, because segments can go either way. Rays and half lines, not so much. But segments, you could name it either direction. BC or CB would be an acceptable answer for that. Okay, so now let's take a look at this next one. We've got segment DE. So I'm going to grab my blue pen here, and segment DE is just this little piece right here that goes between D and E. And then I've also got ray DB. So it starts at D and it's going to go in the direction of B. So I'm going to start here at D and I'm going to go in the direction of B and keep going because a ray continues on and on, right? So there is my ray DB. And what I'm looking for here is I'm looking for the union of these two. I'm looking for the union of this segment plus this ray here. Remember the union, I'm going to marry those two together. So I want everything that has any kind of color, right? Anything that has any kind of color, that's going to be part of my final answer. And so what do I notice about this? I notice that I've got an endpoint right here, okay? I don't go past E. It stops here at E, right? But I do notice that it goes from D and it keeps going all the way toward A, and then it keeps going, right? So my answer is going to be a ray because I've got a starting point here and I've got a direction that it just continues to go. So there's several different ways that you could name your final answer, but it is going to be a ray and is going to start at point E. So we have to start it with an E. But because it's a ray and there are several points along the way, you can pick any of these letters to be part of your answer. You could say it's ray ED, it's ray EC, it's ray EB, it's ray EA. Any of those would be correct. Okay, I'm going to just go with ray EA because it starts at E and it goes toward A and keeps going in that direction, right? Starts at E, keeps going in that direction, covers all the points in between, right? And if you said ray ED or ray EC, ray EB, those would be fine too. Those would be correct. Just make sure you're using the correct symbol above. All right, let's take a look at one here with half lines, because again, half lines seem to be a new thing for most students in geometry. Once they get into this class, they haven't seen the half lines before. So let's take a look at this. In this one, we've got ray AC, and we're going to take that, intersect it with a half line BC. So I'm going to start out with my blue pen. I'm going to draw in ray AC. So that means I'm going to start at A, and I'm going to go towards C and keep going because it's a ray. It keeps going. So start at A and keep going towards C, and it just keeps going because rays do that. Okay, so there's my blue. And now I've got my pink. I'm going to draw in half line BC. So half line BC means that I'm going to start at B, but I don't include point B, right? So I start at B, but I'm not going to include it. So I leave like an open circle there. And this tells me that I'm going to go toward point C, and I'm going to keep going. So C is this way. I'm going to go towards C, and I'm going to keep going. All right, now I'm looking for the intersection of these two. Intersection means only what they have in common. Only what they have in common. So if you take a look at my blue ray here, it starts over here in A, right? And I've got all this space all the way up to point B, but I don't have that in common with my pink line, or my pink ray, half line, excuse me. I don't have all of this right here in common with my pink half line. Okay, so where is it that they start to have something in common? Well, they start to have something in common right here at point B, but not including point B, but everything after that, right? So everything right after point B, they have that in common. So the way that I express that for my answer is what they have in common starts at point B, but it doesn't include point B, but then it keeps going, right? So my answer is a half line. My answer is a half line. It's going to start at B and it's going to keep going in this direction. And just like this problem up here, you can choose any of these points to pair with B. So you could say that it's half line BC, BD, BE. It doesn't matter. Okay, I'm going to put in BE, but you could say again, BC, BD, BE, any of those would be correct because it starts at B and it's going to keep going in that direction. We need to make sure we use the right symbol. It's a half line because it doesn't include point B, but it includes everything after that. All right, so hopefully that helps you with those problems when you see those, both in your book and in the review, and also there will be some of that on the test. All right, so ask more questions about those if you're still having a hard time with them, because I know they can be a little bit tricky, but I'm happy to help with those. The next thing that I've got some questions about is help Mrs. Durr because algebra feels like it was so long ago. And you know what? I've had a couple of students, actually a few students, who have expressed this concern, just saying, so how do we do the equations again as solving for x? That's a great question. And there's nothing wrong with asking that question. If it feels like it's been a long summer since you did any algebra, that's okay. All right, so let's take a look at this. There are two types of these types of line segment problems that you're going to have these equations to solve. So the two types, first of all, one's a midpoint one and one's where it's not a midpoint. So I'm going to start with the one where we have a midpoint. So the important thing here, and by the way, this is section 1.5, a midpoint will break a segment into two equal parts. So if B is my midpoint here, then that's going to break this segment into two equal parts, right? So whatever I've got on this side of B is going to be equal to whatever I've got on this side of B, right? So two equal parts. If they tell you that you have a midpoint, you know you've got two equal parts here. And if they're equal, we can set them apart from each other and put an equal sign in between them. And we've got an instant equation, right? Let's take a look at the next thing that they tell us. They're saying if AB equals 5x minus 2 and BC equals 3x plus 14, find the length of AB. So we're trying to figure out how long this is, and we're just given these expressions here. We're told that AB, so that's this segment right here, is 5x minus 2. And we've got BC, this part right here, is 3x plus 14. Right? So do you see how I can just write in, right, what the expression, what the equation is for this piece right here, and I can also write in what the expression is for this piece right here, and because B is a midpoint, I know that those two are going to be equal to each other. So right away I've got my equation and it's all set up, right? That's the really nice thing about these types of problems where you have the midpoint. You can just write in what this part is, and you set them equal to. Okay. Now, some of you also might look at this and go, oh, wait a minute, Mrs. Durr, how come you don't have the segment symbol above AB and BC? Aren't those segments? Shouldn't we have the segment symbol? And if you remember from the notes this past Monday in class, and I know I wasn't there, but it was shared with you, that when we're talking about the length, or if you're given an equation here like that, we don't need to use that. Only if we're talking about basically the picture of it, when we're talking about the picture, okay, and B is the midpoint of AC, so we're talking about the picture in that case, so we would use the segment symbol here, but we don't need to use a segment symbol if we're just talking about what a length of a segment is. So hope that doesn't cause any confusion for you, but that's why you don't see a segment symbol above each of those. So now that we've got this set up here, I'm just going to bring it down here below. So I've got a little bit more room to work on it. So I've got 5x minus 2 equals 3x plus 14. Right, I'm just bringing that down over here. I've set my two parts equal to each other. And so how do we go about solving for x? So if you remember, solving for x means we want to get x by itself on one side of this equation and everything else on the other side. Right, so what I'm going to start by doing is I'm going to bring this 3x over to the left side. And how do I do it? It's a positive 3x, so I'm going to subtract 3x from both sides. And if this seems basic to you, you don't have to write this part in here. I'm just doing this for anyone who just feels a little rusty, feels like it's been a while since I've done this and need a little extra reminder. How did I move that over? How do I get that over to the other side? What am I doing here? So if it's a positive 3x, I'm going to subtract 3x from both sides. So it's gone from this side. 5x minus 3x gives me 2x. I still have the minus 2 over there on that left side. And I've got 14 left over here on the right side. Now, I want to get this 2 over on the right side because I ultimately want this x term over here by itself, right? I want the x term by itself. So that means I need to take this minus 2 and I need to move that to the other side. Since this is a minus 2, I want to do the opposite and I want to add 2 to both sides. So when I add 2 to both sides, it doesn't change my x term. That's still going to be there, but it cancels that. And so I've got 2x equals 14 plus 2. Okay, so 14 plus 2, let me move this up here, gives me 16. And then my very last step, I want to get x by itself. So in order to get x by itself, I have 2 times x. I want to undo multiplication. And in order to undo multiplication, I use division, right? Those two undo each other, just like adding and subtracting undo each other. So I'm going to divide both sides by 2. When I divide this side by 2, I'm going to get x. And when I divide 16 by 2, I get 8. So I've just figured out that x equals 8, which is great. But is that what I was asked to solve for in the problem? Let's go back and look. I was asked to find the length of AB. Oh, okay, so I wasn't asked to just solve for x. So it's important that you go back and look at what is it that you were asked to find in the problem. Were you just asked to find x, or were you asked to find AB? And in this case, I was asked to find AB. So now I've got to take x equals 8, and I got to use that in my equation over here. So I was told that AB is 5x minus 2. So I'm going to take that 8 and I'm going to use that in place of x, right? So it's going to look like 5 times 8 minus 2. In order of operations, as we do our multiplication before our subtraction, all right? So 5 times 8 is going to be 40 minus 2. And then 40 minus 2 is going to be 38. So AB is 38. And that would be my final answer. Okay. If they asked you to figure out what is BC, well, remember that B is a midpoint, and so this part is equal to this part. So if you know that this is 38, this is also going to be 38, right? So keep that in mind if they ask you to find both parts of the segment in the problem. Okay, so that's how you would do the midpoint problems. The other type of problem that you're going to run into in this section are segment addition problems. All right, segment addition problems. By the way, if I move too fast through any of this, feel free to pause the video, back it up, watch it as many times as you need to. So segment addition ones are going to be different from the midpoint ones because this point here that's in between these other 2 points isn't necessarily going to be equally spaced between the two, right? So as you can see by the drawing, this space here is a little bit shorter, this space here is a little bit longer. They're not equal to each other, right? But let's see what kind of information we have, right? Segment addition says that a small segment plus an adjacent, meaning next to it, small segment, will equal the 2 segments put together. So it tells me if I take RS and I add ST, I'm going to get the whole segment RT, right? So RS plus ST is going to equal the whole segment RT. And over here, we're given those different parts, right? We're given that RS is 11 minus 3x, and we're given that ST is 7x plus 5, and that RT is 24. So this whole distance from here all the way to here is 24. Okay, so this part plus this part is going to equal the whole big segment, right? And that's exactly what we want our equation to look like. So if we can write this on the picture and we get that visual, there it is again, right? I'm a visual person. And if you're a visual person too, writing these things on those segments can probably help you, right? Because it gives you that idea of how do I know what my equation is supposed to look like? How do I set this up? So if you can actually write it on that segment and see it with that plus sign in there, like this segment plus that segment is going to equal the whole big thing, then we have a pretty good idea of how to set up our equation. So as a reminder, we had RS plus ST equals RT. The 2 smaller parts equal the whole big part, right? So that's segment addition. Now I'm going to put in these parts that we had here. So we had 11 minus 3x, and then we had our big plus in the middle, and then we've got 7x plus 5, and that equals the whole big thing, which was 24. All right, so here is the equation that I am dealing with for this problem. Notice this one's a little bit different from the equation of the last problem. I only have x's on one side of my equation, so I'm not going to have to move x's from one side to another. I just have to simplify what I've got. So my first step is going to be to add, I'm going to get my colors here, add my like terms. So I've got, this is an x term and this is an x term, so I can put those together. And then I have my terms that don't have x's, right? So I'm going to put those together. So when I put together my terms that have x's, I've got a negative 3x plus 7x, right? So think about a negative 3 and add 7 to it. What do you get? So you're going to get a positive 4x. So that's what I get by adding my x terms together. And then when I put my terms that don't have x's on this side together, I've got 11 and I've got a plus 5. So I've got 11 plus 5, and when I add those together, that's going to give me plus 16. Okay, so I just put those in those colors so you could see where those numbers came from. All right, so now I still want to get x by itself. I have to get my x term, which is the 4x here. I need to get it on that side by itself. That means that I need to move 16 to the other side. So now is the point where I'm going to start to move things. So in order to move the 16 to the other side, because remember 16 doesn't have an x, I'm going to do the opposite of what this says right here. This is plus 16. So I'm going to do minus 16. Right, so I'm going to subtract 16 from both sides. My 4x is going to stay over here. This will be gone. And I'm going to get 24 minus 16. And when I do 24 minus 16, that's going to give me 8. And then my last step there is I want to get x by itself, and I have 4 times x right now. So in order to undo that multiplication 4 times x, I'm going to divide both sides by 4. So when I divide this by 4, I'm going to get x. And I have to do the same thing over here, divide 8 by 4, and I'm going to get 2. So it tells me that x equals 2. But before I just say, hey, that's my answer and move on, I got to go back and check what was it that they were asking me for in the problem. Okay, and in this one, they're asking me to find x, or st, not just solve for x. So now I've got to go back to st. So st is 7x plus 5. I'm going to take x equals 2, which means I'm going to plug 2 in place of x. So 7, and I'm going to put times 2 plus 5. Multiplication first, so 7 times 2 is 14 plus 5. Now I'm going to add these two together, and so I get 19. So that tells me that st is 19. All right, so this segment right here is 19. And if I were asked what is RS, I could just use some subtraction. If I know that the whole thing is 24 and that this part right here is 19, I could figure out some subtraction, and that would tell me what RS is there. Or I could also plug in the number 2, because x equals 2. I could plug 2 in here, and I would have 11 minus 3 times 2. Okay, and so I could find out that way. 11 minus 3 times 2, 3 times 2 is 6. 11 minus 6 would be 5. So this segment right here would be 5, right? So if you're asked to figure out what both segments are, you can either use some subtraction, 24 minus 19, or you can plug in what you found for x into that part too, and you could solve it that way. All right, so hopefully that helps. These are some of the, you guys asked great questions, and these are some of the ones that, just historically year after year, these are the ones that students kind of get caught on. So I'm really glad that you guys asked some of these questions. There was one more, and again, I'm really glad that this student asked this question. It was about angles, and I couldn't resist. Okay, so this is acute angle, and if you have a hard time remembering what's the difference between acute and obtuse and right angles, maybe this will at least help you keep the acute one straight, right? So acute angles, they're small, they're the cute angles, right? They're the small angles that are less than 90 degrees. 90 degrees would be a right angle, and anything bigger than 90 degrees up to a straight line, that would be obtuse. So acute angles are just the little ones that are less than 90 degrees. All right, so the question was not what is an acute angle, but the question that I got was, I'm having a hard time using my protractor, and I'm not sure because my protractor doesn't have a hole in the center, right? And so a lot of protractors, let me just turn this over real quick so you can see the protractor more easily. So a lot of your protractors might look like this, where you've got the hole in the center and you've got a line that goes horizontally, right? And it helps you match up a side of your angle, and then that little hole there would be where your vertex is. And so a lot of you have these kinds of protractors. But this student had one that looked like this, and it doesn't have a hole in it. It just has a little indentation here, and it has a little vertical line, and then it's got this straight line here. So I want to show you how to use this. And I also have a tiny protractor. If any of you have these little protractors and are having a hard time, there we go. If anybody's having a hard time trying to figure out their little protractor, which looks different than the other two big ones, I can show you that as well. So let me go back to this. All right, this one is hard to pick up. So here's what we're gonna do. We're gonna take this, let me get my paper over here. This place on the protractor that had that little vertical line, right at the very bottom, right where it comes along the side of the plastic, right at that very bottom, I'm going to match that up with the vertex of my angle. So I'm going to bring that over and match it up with the vertex of the angle. And then I also want to make sure, so see how that line right there matches up with my vertex. And then I'm also matching up the bottom of that plastic piece of my protractor along with that side of my angle. And it's really important. You'll notice that all of your protractors are going to have two sets of numbers, one starting at 0 and one starting at 180, right? Starting at 0 and going up, starting at 180 and going down. How do you know which set of numbers to use? It depends on what direction your angle is opening, okay? And the easiest way to figure that out is, what is my side, where is my side touching 0, okay? If I'm using this side of my angle, I'm going to look at where that touches 0, and I'm going to start at 0 and I'm going to work my way up, right? So this side of my angle is right here, it's touching 0. I'm going to work my way up 10, 20, 30, 40, 50, and I see that here's 55, and I'm just a hair over 55, so I would probably say that this angle looks like it's 56 degrees. Right? It's just a hair over 55, so I'd say this is probably 56 degrees if I were going to measure that. Okay. Now, if your protractor has, it's the little one like this, or again, it doesn't have a hole, right? We've got this one here. Oh gosh, we know we're getting a glare on there. Let's see if I can, it helps a little bit. So if yours doesn't have a hole, but it looks like this, again, that little crosshairs right there, where we've got that vertical line and that horizontal line and they meet up, that's where your vertex is going to go. And then you're going to line up your angle along one of these lines down here. So I'm going to put my vertex right there, and I'm going to make sure that my protractor lines up with that side of the angle. Okay, and then I'm going to start at 0 because that's what my protractor right here is going to point to 0, and I'm going to start from 0 and work my way up. And I get about the same thing. Looks like I'm just over 55 degrees, so about 56 degrees there. Now the other place where students have a hard time trying to figure out how to measure their angles is when we've got an angle that looks like this one here. It opens to the left, or maybe they'll give you an angle like this where it's like it doesn't have a horizontal side. It has maybe a vertical side, or maybe it's just the whole thing is just kind of slanted, right? And how do I measure something like that that doesn't have a nice horizontal side like I'm used to seeing? Okay, so don't worry about it. The first thing I will tell you is you can always move your book, right? So if the angle that they give you is not horizontal on one side or another and that bugs you, just move your book. Like, you can twist your book a little bit And it's okay to do that. Move your book around so that you can get it to a place where you're comfortable with it. The other thing that I'm going to tell you, boy, this one is hard to pick up, is notice on this one, I'm going to use this one again because this is the type of protractor that the student had asked me about. So I'm going to line up that vertical line in the middle. I'm going to line that up with the vertex of my angle. And then I'm going to line up the rest of the angle with the bottom of my protractor, right? And my line here is always going to point me to 0. Okay, so that bottom angle line is always going to point me to 0. I always want to start at 0 when I'm trying to measure my angles here. So this time I'm going to use the outside numbers starting at 0, 10, 20, 30, 40, going all the way around here. And notice that it's going to take me all the way on the outside. Okay, it's going to be, we've got 125, and it looks like we're between 125 and 130. So I might say like maybe 127. So I might say that this angle is about 127 degrees, right? And the way you can check yourself to get an idea of did I measure it properly or not? Did I use the correct outside numbers or inside numbers? Let's think about this, right? If I'm using these outside numbers, I'm going to get about 127 degrees, right? I'm going to write that down, 127 degrees. If I were to happen to use my inside numbers and I measured this, this looks like it might be about, maybe like 52 or 53 degrees, right? If I used my inside numbers, if I wasn't sure which one and I just guessed and used the inside numbers and I go, okay, well, that's right around 50, between 50 and 55, maybe that's 53 degrees, right? If I do that, then I have to sit back for a minute and I have to look at what kind of angle is that? Is that cute little angle that we just saw a picture of a minute ago? Remember cute little angles? Those are 90 degrees or less. No, this is a big angle. This guy's bigger than 90 degrees. This is obtuse. So this is going to be a big number, right? So it can't be that cute little size. It's a big number angle. So this one, the way that you would know, did I measure it right? If you ended up getting a small number that's less than 90 degrees, you didn't measure it right. Okay, you should get a large number that's greater than 90 degrees for an angle like this, because this is an obtuse angle. If we look back at this one over here, this one was acute. It's less than 90 degrees. So you should get a number that's less than 90. If you ended up getting a number that was over 90 degrees, then you didn't use the right numbers measuring it. Put your protractor on and try it again. Okay, so hopefully that helps. If you guys have any other questions this week about any of the sections 1.1 through 1.6, shoot me an email. I will put out to you another email that will just cover specifically 1.7. It's not going to be that long. It'll just be a few things to cover on 1.7. And then there's going to be some review work. So let me know what questions you have as you go through stuff, and I will do my best to help you work through them. Have a great week.